this is the very first lecture, Introduction to Database Concept. Here we will talk about what is database, and before going to database, we will talk about what is data. So as I have mentioned, the main topic here is database in this lecture. So database consists of two words, data and base. Base is, like something that is something that is holding something, right? So database is holding data. So what is data? Data is nothing but some raw facts. That's basically how I would like to explain data. So raw facts collected from some events, some objects that is representing some objects. For example, your name is a data. Your ID is a data. Your class or your grade is a data. The class that you have enrolled is a data. So these are data that is representing you. For example, if I want to represent, okay, how do I look? You will say, okay, this man look like, this is a fatty man, this is a skinny man, or this is a basically tall man. So this is how you will define, right? So these definitions are known as data. So data is collected, raw facts from some objects like living objects like us, or some abstract objects, and it is basically collected from some events as well. For example, registration. Let's say registration is an event, right? So for registration, you also might need to have some data. So when the registration was done, what are the things that happened? So these kind of information might be there as data. So information on the other side, this is also very important concept. Information is processed data. When we process the data, that means when the data as we have mentioned, that is a raw facts. So data has been processed, we call it information. For example, I mentioned about your age of student 1, age of student 2, age of student 3, age of student 5. So in this way, I have 10 ages. So this is data. Okay. When I will say, okay, a list of tables contain all these ages of the students, that will become information. On top of that, if I mention average age of the students, would be an information. So something I'm processing on the data would be known as information. And metadata is something that is basically characteristics of the data. What type of data it is? For example, whenever I'm saying age, can anyone say what type of data would be age? Age, what type of data would be age?
Number.
Integer, numerical, yes, right. So this is what is known as metadata. So metadata is nothing but it is the properties or the characteristics of other data. Okay, so whenever I'm talking age is a data. So what is the characteristics of age? So age is a number, age is an integer, age is a whole number. So these concept or these description is known as metadata. Is it clear so far?
Yes, sir.
Okay.
Yes, sir.
Question.
Yes.
You said average age can be considered an information, but can it also be considered data itself?
Yes, if it is collected, if raw facts, I have mentioned like data is nothing but raw facts. So if the fact is there, for example, in Bureau of Statistics, you have average age of Bangladeshi people, isn't it? So if that data is there, then you can consider this is a data. But whenever we are processing data, we will be getting information. For example, I have age of students, 10 students. I process the age and I get average age. Then definitely it should be known as information. Clear?
Yes, sir, clear.
Okay. Let's go back to the next slide. So as you can see, these are different way of representation of the data. Now, if you look into the diagram on the bottom, we have two charts, right? One is pie chart, another is line chart. Can anyone would be able to tell me the line? Can anyone would be able to describe the line chart? What do you understand from this line chart?
So line chart can be described in any line, like
no. Just
Sir,
explain me what you found, what
then,
you basically get once you look into this chart, and you can explain. You need to explain me the chart.
sir,
Yes.
the number of students enrolled over a unit of years.
Yes, number of students enrolled over a period of time from 2005 to 2010. What else you can say from there?
And the
From
estimated
2009 to 2010, there is a estimated number of students, which is
Very
not
good.
clear.
Very good. Actual data is from 5 to 9. This is the actual data. And 9 to 10 is basically estimated. So they have estimated the number can go up like that. So what else you can see? What else you can tell me from there?
So there is a sharp incline in student intake from 2005 to 2006.
I should not say sharp incline. I should not say sharp incline, but definitely there's an incline trend, right? You're absolutely right. So there is an incline trend from in the overall. If you cut it in a linear way, you can see this would be this is a incline. There's an incremental trend in the data, right?
Yes, sir.
Okay. So like these are the concept, or these are the knowledges that you are having by looking at this information. So this is not data, this is information, because we have processed the data. So data was, for example, which year, how much was the enrollment, that was the data. And once we process this, that become a piece of information. And looking at this piece of information, I have, based on my knowledge, I have retrieved some new knowledge and I add on with that. Okay. So with the pie chart, what you can tell me about the pie chart?
But management has accounting has the most number of employees.
So the pie chart shows the majors students took, the percentage of number of students, the different majors.
Exactly. Distribution of students
Yeah.
with respect to their majors, right?
Right.
Very good. And it has been led by accounting. Accounting is basically 1/4 of the students are doing accounting, right?
Right.
And second highest is basically management, which is 20%, followed by marketing and IS, which is 15%, and others is basically others, which is also 15%, and finance is 10%. So what it shows you, or what it tells you?
So it basically shows us the information out of 100%. How many students can there be in each section?
Okay, the information I have received is correct, right? What I can do with this information?
We can predict the actual number.
Okay, which has been done in the second graph. They have estimated number. What else? For example,
we have a visual representation of the, what is it called? I don't know, the pieces of every, like marketing, finance, others.
Right. So for example, as I know, the enrollment trend is basically increasing. As an institute, what should I do? If I know I am getting more students over the period of time, what should I do?
Since we know the percentage of students that's going to increase, we can act accordingly.
What we should do?
We have to increase the capacity of the courses.
Very good. That means you need to hire faculty member, right? You need to build buildings. You need to have the facilities so that you can accommodate more, right?
Right. Also allocate course slots.
Exactly. That means you need to offer more courses. Very good. So these are the strategic decisions that would be taken by the strategic decision makers once they would be looking at the graphs that would be shown by you. Okay.
Right.
Are you clear so far?
Yes, sir.
Yes, sir.
Okay. So these are the things that we will be doing. Okay. Throughout of the course, we'll try to analyze what's going on and how things is there and what can be done to improve it further. So this is basically some metadata as I already have mentioned. For example, data item is course. Course is basically alphanumeric, as you know, CSC 303. It is alphanumeric. The length here they have mentioned it is 10 length. They have mentioned about this is basically a description. It contains course ID and name. Source is basically academic unit. So you can see the metadata is describing the data itself. Clear? Section is integer. Semester is alphanumeric. Name is basically alphanumeric. ID is basically integer. So they have defined the type of data based on their own experience. So based on the availability of the data, they have defined their metadata. But in our case, in IUB, for IUB, if I consider ID, what type of data would be ID? Number?
Integer.
Metadata.
Yeah, numerical, sir.
So
Yeah,
metadata.
Metadata, yes. What kind of data would be ID?
Sir, integer. Integer, sir.
Integer.
Huh?
What type of data would be ID?
Sir, course ID, alphanumeric. I think.
No. Your ID, student ID.
Sir,
Oh,
integer.
Integer.
Integer, yeah.
Integer.
Or character. Because
No. You have to say any one of these. Okay.
Integer.
Number or character. Integer.
Integer.
number. Okay.
Integer.
It should be number.
Yeah.
It should be number. Now someone who is saying it is character. Sorry, it would be character. Can anyone explain why it should be character?
Because you're not doing mathematical operations with it, so it doesn't necessarily have to be integer.
Good, very good question, very good answer. Anyone else? The answer is basically you are not adding those things, you are not basically deleting those things from one number to another. So why it should be a number? Very good.
Exactly. It's more
Very
optimized that way if you don't use integer.
Exactly, and on top of that, I might need to extract few components from there to get the semester, to get the year, right? Because like the first two digits of your ID is the year. The third one is basically semester, isn't it? So I might need to perform some string operation. That could be one of the reasons why it should be string, not number.
Right.
Anything else? Okay. Answer one question. So if I store a value 00001, what would be stored as number? I'm saying 00001. What should be stored as number?
1.
Sir.
Sir, 1.
1, right? So
Yes, sir.
putting 0 in front of any number, does this make any difference?
No.
So automatically the 0 should be
Cancelled.
or the 0 won't be stored, right? But
Yes.
think carefully, the students who have joined IUB in 2000, what would be their ID? How their ID would start? Students who joined in 2000, in year 2000.
00, sir.
Very good, 00. So if you store ID as number, what will happen? The 00 will gone. So the 7 digits or the 7 numbers that you are having, you won't be having that anymore, right?
Yes, sir.
So this could be another reason why we would be having ID as student ID as alpha numeric or characters. Okay. So now we are going to discuss about the traditional file systems. So typically what happens if you think about register file, if you talk about manual file where basically we'll be writing your names and your IDs, whatever the information we want to keep. So if I have multiple system, for multiple system, I would be storing the information in multiple files. So for example, I have one system called order filling system, another is invoicing system. So you are coming to me asking for a particular product. I'm writing what product you have asked for. I write those product in the order filling system. And in invoice system, I have your detailed billing information. So you ask me, okay, sir, I want to change my address. So I change it. So where I change it while I am using your order filling. So in the order filling, I change the customer information. As you can see, the customer file is there. So in the order filling system, I change your registered. In the order filling register, I change your address. But when it goes to invoicing, you will find there is a customer master file which hasn't been changed because I have a separate file for invoice system, isn't it? So in that way, if I have multiple system and multiple files for those systems, it would be very difficult to manage those things. So how can we get rid of that? So to get rid of that, we can simply have very sophisticated system. We can have very sophisticated system. That means we will be having the system and the files should be common. There won't be separate files. There will be single files. So if I have single files, then basically if I make change in a single file, that would be reflected in everywhere. For example, the lectures that I have shared with you, that is there in my Dropbox, right? So if I make any changes in my Dropbox, what will happen? All of you will get the updated document, isn't it? But if you take a copy of the file in your local machine, and if you start getting yourself ready with that, and if I make any changes in my file, what will happen? You will be working with outdated data, isn't it? So these are the concepts that you must need to understand while we are talking about traditional file processing system and current online file processing system. So the disadvantage programs are dependent. There will be data duplications, limited data sharing, lengthy time, maintenance issues. So these are some problems. Now in database approach, where we will be having data application, we will be having data model, we will be having entities, we will be having relationship database, and we will be having database management system. So at the beginning, we have raw data. So based on the data, we make a model, and using the model, we prepare an application which would be used by the user. We have on the back end, we have a physical structure, and physical structures is managed by a database management system. So that's basically how database approach is working. Any questions so far?
No, sir.
Okay. So advantages, as mentioned previous. So this is independent. There is redundancy, less redundancy. Inconsistencies are removed. Data sharing is there. Production time is basically increased productivity and enforce the standard. So these are some advantages. Apart from that, we have data quality, accessibility, program maintenance, decision support. So these are some advantages of using database. So that's why we would be using database management system. Now, once we are talking about cost and risk of database management system, you must need to also understand, because database management has its own cost. So manually, the files, the cabinets, all those things are there, those will go. And what will happen? So these are known as non-computing devices. Your pen, the pencil, the books, the cabinets. So these are all non-computing hardware. These are not computing hardware. But when we are talking about database and typical database, we are talking about computing hardware. You need a machine, you need RAM, you need ROM, you need software to run those things. You need a database to store those data. So there is a cost associated with that. There is risk associated with that. You also need to understand those things. So cost means you need to have the machines, the installation cost, the software cost. So these are there. So you have to incorporate those things. You have to consider those things. At the same time, risk is there. So what will happen? What you will do if the machine got broken? So what you will do if the machine got hacked? So there has to be some contingency plans as well. So these are the things that we are talking. So that's why the backup and recovery system is important. And basically, organizational conflict should be there. So in organization, there are different types of people who would be storing different types of data. So there should be some sort of conflict would be going on. Components of database environment. So these are some components. We have computer-aided software engineering, which is known as CASE. We have repository, which is basically where we will be storing data. We have DBMS, which is managing the data. We have database, which would be storing the data, and we have application programs, which would be used by the computer, which would be used by the users. So this is basically different components of database environment. Apart from that, we have user interface through which user will interact with the system. We have data and database administrator who would be administrating the data and database. We have system developers who would be developing the system, and we have end users who would be using the database. Any questions? Any questions so far?
Are these definitions important for our exams?
No. These are not. Because exams are open book. Okay, you can use the lecture sheet. You can open the book, so there should not be any problem from my side.
So what is system developers?
Developers are the programmers who would be programming the interface or the database. They're the developers. Okay. Okay. Let me proceed. So please stop me if you get something that is not clear. So application of database can be used in a personal level. So for example, I want to manage my daily accounts. I want to do it in a database. So I can do that. So I can manage my personal account using database. I can take backups of the contents using database. I can manage my library using database. I can manage my collection of CDs using database. So these are the personal data. These are the applications where personal database can be used. So as you the next part here, we have application. As you see, this is the structure of the database. Database can be there in two-tier structure. Two-tier means there are two parts. One is server, another is client. Client is basically who would be using it. Client could be the project manager, the end user, the developers, the analysts. They are basically user, and the backend where we have the server where the data store would be there. So they would be using the client would be using the database to get the information or to store the information. Developer would be using the database to design new module. Programmer will program in the database. So this is basically how the client server database model works. So we have one server, we have multiple clients. We can have multi-tier structure where we will be having the clients, we will be having the web applications, and we will be having database level data server. So this is known as multi-tier database, multi-tier client server approach. So client is basically myself. I'm a client. I am basically, when I am typing Google, where basically I'm hitting? You have any idea? Once I type google.com, where do I go? Any idea? Any idea? If I type iub.edu.bd, where do I go?
Server.
Exactly. I go to IUB web server. Okay. So the data, for example, when I am giving attendance, I'm going to IRIS, I'm going to the server, the application server, that is known as web server or application server. But when I give attendance, this application server somehow interact with the database, which is there in the data server, and it store information from there, or it store information there and retrieve information from there. So this is basically how this three-tier architecture works. So we are client, we're using browser, database server is there, so which is basically storing the data, and we have the web server, or we have the application server, which basically handle the applications or handle the web pages. Then basically,
I had a question.
Yes.
As you explained in this slide, at the end of our course, will we be able to build something like this?
That is our plan so far.
Okay, thank you.
Okay. Enterprise, for the enterprise, for example, IUB is using IRIS. So IRIS is basically ERP for IUB. So this could be one of the example for how enterprise are using databases for their purpose. And finally, this is the last slide, I believe, the evolution of database. So from fat file system, which was started from 1960, we have now data warehouse, which is basically going on from 1990. So this is basically history. We have fat file system, we have hierarchical database, we have network database, we have relational database, we have object-oriented database, we have object relational database, and finally we have data warehouse. But this is not the final version. We have big data, concept of big data, where basically we are saying about NoSQL, which is basically example could be MongoDB. So these are the new area. So these are the new trends. So this is basically the history of database. So evolution of database. So is there any question? Because this is history. You don't need to remember those things. You don't need to, you just, I'm just introducing the concept with you. So that's all from me today. So now I would like to take questions from you. Any questions?
Sir, can you please explain what is a hierarchy again? I forgot a bit.
Sorry, what is
hierarchy?
Okay, let me stop the recording for the time being.